Alright, now an archer's is pulling back at the midpoint of the bowstring with a horizontal force of 162 newtons. Now, what is the tension in the bowstring? Now our two distances is 72 centimeters and 3.5 cm at the bottom, both given. What I did for this was I found the small segment, the bowstring, which is touching the archery's finger, and that I know that that piece of string is in equilibrium. So so it has the net force acting on it has to be 0. Now I drew my force body diagram up here, with my axis being the normal y and the y up and the x horizontally. And I know that the force exerted on the string by the force exerted on the fingers is in equilibrium throughout on all the forces of the bow touched by the archery's fingers throughout the string is at all equilibrium throughout the bow, so that we can just jump right in from here. And for the measurements given, we can find that angle theta is the sine of angle theta is equal to opposite over hypotenuse, which is equal to 35 cm divided by 72 centimeters, which is equal to 0.486 centimeters. And then we take angle theta, which is equal to the inverse sine function of times 0.486, which is equal to 29.1 degrees. And then here we can see that the x component of the tension force exerted by the upper end of the segment is equal to tension sub x equal to negative t sine angle theta. And then the x component done at the lower end of the string is mentioned earlier, that they're all going to be the same tension earlier, and that is equal to the sum of the forces in the x direction is equal to negative 2t sine of angle theta plus f sub a is all equal to 0. So now that we know that, we're ready to solve for t. So t equal to f sub a divided by 2 sine angle theta, which is, we plug in our values for that, we get the tension in the bowstring is 170 newtons. So that is your answer for my second forces reassessment.